I tried making roller skates with electric motor, but say for instance like a person has two leg stands, one the front, as you can see, like and another is, so say for instance this is left and this is right, and another one is this is right and this is left. So stance number 1 is this and stance number 2 is this. So if on this stance the roller blades are here, then on level floor this can be like a manual step. And stance number 2, the roller blades, when the right side comes in, the roller blades are here and the roller blades are here. So when you go from stance 1 to stance 2, it the person moves forward. And now if the roller blades are, say for instance, attached to a motor, and if I can do it with a bearing, but if I instead attach a motor with a wheel, then not only will it rotate, but it might also generate energy. So there is a bit of manual pedaling in between, so that would mean that I can convert that step energy into electricity. But the thing is, I tried with DC motor 5 volt, but that doesn't usually work because that energy is really low. Then I tried using a sandal. So a sandal shape is kind of like this, and then there is a V shape and hook, and one hook is there, one hook is on the other side. But the sandal, and there is a thickness. There is thickness this much on the sides, so that would mean I can put on nails and tie threads or copper wire, any of the, like on metal I can think of like copper wire, so that they would have high tensile strength. And some people make springs with metal. If you see on the rickshaw on the side, old rickshaws, there were like a I-shaped metal bent and screwed, so they kind of act like a spring, but also have high structure strength because of metal. And they don't bend much, but because of the they provide strong structure because of metal, but the opportunity cost is they don't bend much, which is fine. We don't need a vehicle to bend much, and that's why rickshaws use this spring structure a lot. Used to. Anyways, so back to the rubber sandal sole. At the side we can use springs, and if I attach a motor on either side and make holes, like use a knife to make holes, and then place the motor there and use super glue to attach the motors in. So every step the rubber would hold the motor. That was the initial idea, that whenever the steps are here, the pressure is here, then or the pressure is here, then this would bend, which would grip the motor, and thus adding on to the grip of the super glue at the base. But that kind of didn't do it because the motor seems to be attached, and it doesn't seem to let go, and the super glue seems to work fine with my step pressure. But the thing is, the new question is, how do I make the wheel? And the DC motor shaft is really thin. So what I did was bottle caps. Bottle caps, you can use nails, use small nails to punch through holes, 3 holes like a Venn diagram, and then try to push the shaft in, and it will open up to exactly the size of the shaft, and it will be tight. And so on, the motor shaft can have a wheel, and you can use a blade, or you can you can use a blade or scissors to make the shaft thinner. I mean the cap head thinner, so that it almost looks like a wheel. But it doesn't matter, because the thicker the wheel, the better. If the shaft protrudes out even slightly, that's better. Because the bottle cap, the side structure, it has like grooves in there, and those grooves help in the grip. But even so, with the bottle cap, the grip wasn't enough. So what I did was, there's the bottle structure. I made X shape, but with the nails, and pushed the nails through. And when I pushed the nails through, the hat of one nail held another hat of another nail, so making the structure rigid. And usually the bicycle wheel structure, or any wheel structure, is if you cannot surround the wheel, then make a triangle with all of them 120 degrees. So that's like budget wheel. Each line should be 120 degrees apart from another. That makes a total of 180 degrees symmetric. But I wanted to make it more rigid, so I made an inverted triangle as well as a triangle. So the inverted triangle 180 degree apart, and the initial triangle also 180 degree apart. So that makes the wheel. And these DC motors, sometimes in the market you get like a fan blades, and you can cut off these blades, and the center part would be like a cap, and you can use super glue to attach to make the cap, so that the final wheel would be like the bottle cap, and inside the shaft you can attach the fan blade cap to seal it in, because you cannot like use super glue and attach the pins. They're like, the surface area is too thin, and it will like break apart. But the cap has a larger surface area to attach to, so it will stick. But the biggest problem is that the rubber sole is rubber. So whenever the pressure is at the center from the top, the wheel would bend outwards. The wheel would bend outwards, and it will be like a squashed sole, with the wheels being like a drone head. But that doesn't help, because I need the wheels vertical, not horizontal. So the wheels have to be vertical and not horizontal, which is the main problem, because the pressure comes in the center. So I need something to push the wheels towards the center so that it stays vertical. Which kind of seemed the problem, but then they found a solution that is the motors and the shaft and the wheel. So I put some nails there, and nails at the side as well, and nails here, and I cut a small part here so that I can put nails here inside. All has to be at the side, and nails here as well. So if I use ropes and nails to make loops this way, and ropes and nails to make loops this way, and then push the nails inside, then the ropes will be secured, or not even ropes, like threads, and this would push the ropes inward, and also I might bend the rope and put a nail in there, but the nail from the surface I can make a slight angle and then push it in, so the nail wouldn't come out of the surface. So even if the nail comes out, the nail will come out from the front and not direct vertical. And so there I make the loop, and if I make a loop here, it would be like a U shape, and the U shape would bend tight here, so that would put the pressure this way, and if it puts the pressure this way, the wheels would stay vertical. And if I put nails here and nails here as well, and use threads to make a tension here, and that would allow the backside to push downward, so backside to push upward. I mean, this side to push upward, and this side to push downward, making a momentum. And if this side is pushed, this side to push downward, and this side to push upward, making a momentum, which if I can do enough, then that would cancel the foot force, allowing the sole to stay lifted and the wheel to stay vertical. And the last technique was, if I spread the force, making it like a Spider-Man cobweb from a center point, that would spread out the force evenly. And even from the side, on this axis, if I spread out the force from the thread and spread out the force this way to hold the motors, that would spread out the force evenly and provide even lift along the surface. And finally, what I made was this one. And you can see that on the side, I use nails on the side and nails at the front as well. Needs a bit more rework, but it needs a bit more work, because I need more nails and more ropes. And I used a bit of copper wire as well on this part, and carefully on this part not to touch the motors, and ropes as well, for extra tension, raw force, and copper wire for a bit of tensile strength.